Today we shall be starting off with capacitors and inductors. Okay, it's a pretty basic topic and nothing much very difficult. Okay, you need to have some certain formulas and certain rules and regulations, and that's it. There is no much brainstorming over here. Okay, simple things to keep in mind, and that's it. The charge stored by a capacitor is in the form of electric field. Okay, we have the certain formula, capacitance, volts, and certain formulas regarding this stuff. The element is linear and non-dissipative. Okay, voltage at a certain time across capacitor is given by this formula. Instantaneous power delivered by capacitor is given by this formula. Total energy stored is given by this formula, and it is always positive or zero, hence it is called a passive element. Okay, characteristics: no current through capacitor if voltage is not alternating, so it acts as an open circuit to DC. Okay, and when the voltage is constant and current is zero, it can still store some finite energy. It resists abrupt change in voltage, never dissipates energy, but a physical capacitor does dissipate some energy, because we have that what do we say, that dielectric medium in middle, so that has some resistance which leads to some energy dissipation. So when we have capacitance in the form of series, we have this formula for equivalent capacitance, and when we have capacitance in parallel, we have certain formula. Okay. Next thing we have is about inductor. It stores energy in the form of its magnetic field, and inductance is a property of an electric device by which time varying current through the device produces a voltage across it. We have this particular formula for inductance, and things regarding permeability of core, length, and so on and so forth, means we are talking about things that are in an inductor. Then we have inductance. Okay, it is a linear element. Then we have power delivered, energy stored. Okay, these are the certain formulas you have to keep in mind, because we are having questions from this particular section every year. Okay, you need to just learn these formulas and just practice not more than 2 or 5 questions. Okay, and you can be good at it. Same here. The energy stored is always positive or zero, hence this is also a passive element. Now let's talk about characteristics. No voltage across inductance if current is not alternating, hence it acts as a short circuit when applied DC supply. Okay, energy can be stored when voltage equals to 0 and I is also constant. Let's talk about inductor resists abrupt change in current. Here capacitors resists abrupt change in voltage. Here inductor resists abrupt change in current. Okay, dissipation energy, and because some resistance is there from the coil, because you are making a inductor out of a coil, a metallic coil, so that is bound to have some resistance, so that is why it also dissipates some energy. A practical inductor dissipates some energy, but ideally we take into consideration that it is not a dissipative element. Let's talk about combination. This is a series combination here right now, and for finding out the equivalent we are using this particular formula, and for parallel combination we are using this particular formula. And this is all for capacitors and inductors.